viewers and dear students, I hope all of you will be good and healthy position. Today we have a derivative of hyperbolic function. Let's come we start the derivative of sine hyperbolic function, that is sine hyperbolic function. It stands for hyperbolic. So how we can derive? Let's look. We suppose that as I had sine hyperbolic is equal to, let's y is equal to sine hyperbolic x. As we know that the value of sine hyperbolic is e power x minus e power minus x divided by 2. Now we are find the derivative of this function differentiating. Now differentiating with respect to x on both sides of this equation. So dy by dx, dy by dx is equal to dy by dx e power x minus e power minus x divided by 2. Now here 1 by 2 is constant value we take from the outside of the integration e power x minus e power minus x. If we are taking with respect to x dy by dx, so 1 over 2 derivative of e power x minus derivative of e power minus x. We can write 1 over 2 derivative of ex according to the formula, and further derivative of x and derivative of e is minus x and further derivative of minus x. So we can write dy by dx, y dy by dx is equal to 1 over 2 e power x and further derivative of x is equal to 1 minus e power minus x and further derivative of x is equal to minus 1. So 1 over 2 e power x minus into minus plus e power minus x. So that is we get 1 over 2 e power x plus e power minus x. So we can write this result e power x e power minus x divided by 2, which is the result of cos hyperbolic x. So the derivative of y dash sine hyperbolic is like cos hyperbolic x. So the same process we are using now. We are differentiating with respect to x. dy by dx is equal to dy by dx cos hyperbolic x. Now we substitute the value of cos hyperbolic x value. We can write put the value of ex plus e power minus x divided by 2. So 1 over 2 is constant value we take from the outside of the derivative, and ex plus e power minus x. Now individually differentiate the value y dash. We can write dy by dx and 1 over 2 dy by dx e power x plus dy by dx e power minus x. Now we can write 1 over 2 e power x and further derivative of x plus derivative of ex minus x and further derivative of minus x. So 1 over 2 e power x and x derivative is 1 plus e power minus x and further derivative x is minus 1. So 1 over 2 e power x minus into plus minus e power minus x, and if we divide this result e power x minus e power minus x divided by 2, that is the value of sine hyperbolic x, that is the derivative of cos x. Tangent hyperbolic x. So let y is equal to tangent hyperbolic x. Tangent hyperbolic x we can write sine hyperbolic x divided by cos hyperbolic x according to the formula tangent theta is equal to sin theta divided by cos theta according to this formula. Now differentiating with respect to x dy by dx is equal to dy by dx sin hyperbolic x divided by cos hyperbolic x. Now we are using here the quotient rule. According to the quotient rule, here we are using quotient rule. Y dash is equal to y dash. For example, y is u divided by v. U is belongs to sin hyperbolic and v belongs to cos hyperbolic. If we are finding y dash, so we can write v and u dash minus u and v dash divided by v square. That is the value of quotient rule, division rule, if we in case of derivative. So dy by dx, dy by dx is equal to cos hyperbolic x and derivative of sin hyperbolic x minus sin hyperbolic x and derivative of cos hyperbolic x divided by cos hyperbolic x whole square. Now cos hyperbolic x derivative of sin hyperbolic is cos hyperbolic x minus sin hyperbolic x and derivative cos hyperbolic is sin hyperbolic x divided by cos hyperbolic x whole square. So we can write cos hyperbolic x, so we can write cos square hyperbolic x minus sin square hyperbolic x divided by cos square hyperbolic x. Cos hyperbolic is and minus sin hyperbolic is equal to 1. So that is equal to, and here we can write the cos square hyperbolic and we can put and hyperbolic square. Sorry for that one. Sin hyperbolic square dy by dx sin hyperbolic is equal to 1 divided by cos hyperbolic square x. Cos hyperbolic square is equal to secant hyperbolic square x. Hyperbolic is secant hyperbolic x. Let y is equal to secant hyperbolic x. Secant hyperbolic is equal to 1 over cos hyperbolic x. Now we are using here division rule. According to the division rule, so dy by dx is equal to, that is cos hyperbolic x and derivative of constant 1 minus and 1 derivative of cos hyperbolic x divided by, according to quotient rule, cos hyperbolic x whole square. So the constant value is 0, cos hyperbolic is 0 minus 1 and cos hyperbolic is sin hyperbolic x divided by cos hyperbolic square x. This is 0 and we get here minus sin hyperbolic x divided by cos hyperbolic square x. So sin hyperbolic x is, you can write this one minus sin hyperbolic x divided by cos hyperbolic x and cos hyperbolic x, because square is separated to each other, and this result is equal to minus tangent hyperbolic x and 1 over cos is equal to secant hyperbolic x is the required proof of the derivation of the secant hyperbolic x. Thank you very much for watching. Please subscribe my channel and share this video with your friend. Thanks again for watching.